In this video, I'm going to be finishing up that Chapter 8, Part 2 homework review on the back side where we're actually factoring these problems, numbers 1 through 18. So the first problem here has a trinomial, 3x squared plus 11x minus 20. The first thing I always do when I factor, according to my flow chart, is to look for a GCF. So that's what I'm going to do. I see I have a 3, an 11, and a 20. There is no number that goes into all three of those besides 1, so there's no GCF to factor out. Second thing I notice is that it has 3 terms, okay, and that's where it gets a little complicated. If it has 3 terms, it's either going to be an a equals 1 trinomial, a greater than 1 trinomial, or it could be that special case perfect square trinomial. If it's 3 terms, I would highly recommend checking to see if it's a perfect square trinomial first. I see a 3 and a 20. Both of those numbers are not perfect. Therefore, I know it's not a perfect square trinomial. So that means it's either going to be, since it's not this, an a greater than 1 or an a equal to 1 trinomial. And in this case, we see that a is a 3, so that means a is greater than 1, which means, according to my flow chart, I'm going to do that split the middle method, which is a combination of big X and grouping. So I'm going to start my process here with a big X. On top, I have a times c. On bottom, I have b. This is a, b, c. So on top, I have a times c, which is 3 times negative 20, which is negative 60. On bottom, I have b, which is a positive 11. The two numbers that multiply to be negative 60 and add to be 11 are 15 and negative 4. After I do my big X method, I'm going to do that split the middle step. So I'm going to rewrite the first term, 3x squared, and the last term of negative 20. Okay, just bringing those down. And then I'm going to create 2 new middle terms here with whatever I got here in my big X. So I'm going to have a positive 15x and a negative 4x. Now, the reason I'm writing x's on these is because if I combine these, 15x minus 4x, I would get back to that original 11x in the middle. That's why it's called split the middle. I took this middle term and I split it into 2 pieces. Okay, so again, I did big X, I did this split the middle step, and then now that I have 4 terms, I'm going to do grouping. The GCF of this first pair, well, the biggest number that goes into 3 and 15 is 3. They also each have an x in common. So I'm going to factor that out. 3x squared divided by 3x is x. 15x divided by 3x is 5. The GCF of the second pair, the biggest number that goes into negative 4 and negative 20 is negative 4. Negative 4x divided by negative 4 is x. Negative 20 divided by negative 4 is 5. You know you did your grouping correctly if these 2 terms match. They do, so I have x plus 5. And then I also have 3x minus 4, and I get that from the 2 GCFs here outside the parentheses. Now remember, anytime you factor on any of these problems, if you want to check to make sure your answer is correct, you can do claw or box method, which we practiced on the Chapter 8 Part 1 lessons and tests. You can do claw or box method, and if you do it correctly, you should get back to your original statement. So that's how you can always check your answers. For number 2, again, the first thing you always do is look for a GCF. I have a 7, a 28, and a 21. 7 goes into all 3 of those numbers, so I'm going to factor that out. If I factor this out, I have 7x squared divided by 7, which is x squared. Negative 28x divided by 7 is negative 4x, and 21 divided by 7 is 3. So again, I look for a GCF, I find that it's 7, and I factor that out. Then I look at my parentheses, and I see I have a trinomial. And the first thing I would do is look to see if it's a perfect square trinomial. X squared is perfect, but 3 is not perfect, so it is not a perfect square trinomial. Then I would look to see what is a. In this case, a is equal to 1. So I'm going to do that big X method. On top, I have a times c. This is a, b, c. So a times c in this case is going to be 1 times 3, which is 3. b is negative 4. So the 2 numbers that multiply to be 3 and add to be negative 4 are negative 3 and negative 1. Okay, when a is equal to 1, I just use these to write my 2 factors, x minus 3, x minus 1, and then I can't forget that GCF of 7 out here in the front. For number 3, the first thing I always do is look for a GCF. There is no number that goes into all of those numbers, 16, 24, and 9, so there's no GCF to factor out. Second thing I notice is that it has 3 terms. Again, if it has 3 terms, the first thing I would do is look to see if it's a perfect square trinomial. 16y squared is perfect. It's 4y times 4y. 9 is also perfect. It's 3 times 3. But I can't just stop there. I also have to check the middle term. And remember, the formula for that is 2ab. So 2 times 4y times 3 is 24y, which is my middle term. So that does check out. So if the first term is perfect, the last term is perfect, and the middle term checks out, this is a perfect square trinomial. So we can do this kind of shortcut. I'm going to have 2 factors. Each of them are going to have a 4y. Each of them are going to have a 3. And then they're actually both going to have the same exact sign, and the sign is determined by whatever sign is right here in between the first and second terms. So if this is an addition sign here, then both of these are going to be addition. These are identical, which means I can actually rewrite this to be 4y plus 3 squared. Okay, because squared means I have 2 of them. Looking at number 4, the first thing I want to always do is look for a GCF. There is no number that goes into 1, 7, 2, and 14. So there's no GCF here. Second thing I see is that it's 4 terms, and the only possible thing to do when it is 4 terms is what we call factor by grouping. So that's what I'm going to do here. I'm going to group the first pair, group the last pair. I find the GCF of the first pair. I see that they both have at least an x squared in common. So I'm going to factor that out. X cubed divided by x squared is x. Negative 7x squared divided by x squared is negative 7. The GCF of the second pair, the biggest number that goes into 2 and 14 is 2. 2x divided by 2 is x. Negative 14 divided by 2 is negative 7. I know I did it correctly because this matches that. So x minus 7 and x squared plus 2. For number 5, the first thing I always do is look for a GCF. There is no number that goes into 1, 5, and 6, so there's no GCF to factor out. Second thing I notice is that it has 3 terms. So again, if it has 3 terms, the first thing you should do is look to see if it's a perfect square trinomial. X squared is perfect, but the 6 here is not a perfect number, so this is not a perfect square trinomial. So you can't do that shortcut method. Again, instead I'm going to look to see what A is. A in this case is a 1. So if A is a 1, we do that big X method. On top is A times C, so I have 1 times negative 6, which is negative 6. On bottom I have B, which is negative 5. The 2 numbers that multiply to be negative 6 and also add to be negative 5 are negative 6 and positive 1. If A equals 1, I can just go straight into my factors of A minus 6. I'm sorry, not A minus 6. X minus 6 and X plus 1. For number 6, the first thing I always do is look for a GCF. I see that all of these numbers are even. That means 2 goes into all of those numbers. And I also see that they all have an X in common. So they actually have a GCF of 2X. I'm going to factor that out. 2X cubed divided by 2X is X squared. Negative 20x squared divided by 2x is negative 10x. 50x divided by 2x is 25. All right, so I factor out a GCF of 2x. Then I'm left with a trinomial here in the parentheses. Again, if it's a trinomial, the first thing I would do is check to see if it's a perfect square trinomial. X squared is perfect. 25 is also perfect, but I can't just stop there. I have to check that middle term. 2ab, which means 2 times x times 5. 2 times x times 5 is 10x. That is my middle term here. So this is, in fact, a perfect square trinomial. So I'm going to have 2 factors. Each of them are going to have an x. Each of them are going to have a 5. And then they're actually going to have the same exact sign, and it's going to be determined by whatever sign is right here in between the first and second term, which in this case is subtraction. And then I can't forget my GCF of 2x here in the front. Now again, x minus 5 times x minus 5 can be simplified to be 2x times x minus 5 squared. Now for number 7, the first thing I'm going to do is look for a GCF. I see a 16, a 40, and an 8. 8 goes into all 3 of those numbers. Then for the variables, I'm going to look for the smallest exponent. I have a 2, a 4, and a 1, so I'm going to have an a here, a to the first. For the b's, I have b to the 5th, b cubed, and b to the 7th. b cubed is the smallest. Now I'm going to factor that out. 16 divided by 8 is 2. A squared over a is a. B to the 5th over b cubed is b squared. Negative 40 divided by 8 is negative 5. A to the 4th over a is a cubed. B cubed over b cubed cancels. Then for the last term, 8 divided by 8 is 1. A over a cancels, and b to the 7th over b cubed is b to the 4th. And that's all we can do on that type of problem, is factor out a GCF. For number 8, the first thing I always do is look for a GCF. There is no number that goes into 36 and 49, so there's no GCF to factor out. Second thing I notice is that it's 2 terms, so I'm looking for a difference of 2 squares. This is a difference. It has a subtraction sign. 36x squared is perfect, and so is 49. So this is a difference of 2 perfect squares. 36x squared is 6x times 6x. 49 is 7 times 7. Each of them is going to get a 6x. Each of the factors is going to get a 7. And then refer to your flow chart to remind you that for a difference of 2 squares, 1 needs to be addition and 1 needs to be subtraction. So I'm going to have 6x plus 7 and 6x minus 7. For number 9, the first thing I always do is look for a GCF. There is no number that goes into 2, 7, and 15, so there's no GCF to factor out. It's a trinomial, so again, I would recommend looking to see if it's perfect. I can see just from looking at the 2 and the 15 that it is not perfect because neither 2 nor 15 are perfect numbers. Then I look to see that a is greater than 1. So I'm going to do this split the middle process. To start, I'm going to do big X. On top, I have a times c, so I have 2 times negative 15, which is negative 30. On bottom, I have b, which is negative 7. The 2 numbers that multiply to be negative 30 and also add to be negative 7 are, negative 10 and 3. After I do my big X method, I'm going to do my split the middle process. So I have 2x squared, and then I have the negative 15 down here. And then my 2 middle terms are now going to come from what I got here on my big X. So I'm going to have a negative 10x and a positive 3x. So I did big X, I did my split the middle step, and then now I'm going to do my grouping. The GCF of this first pair is 2x. 2x squared divided by 2x is x. Negative 10x divided by 2x is negative 5. The GCF of the second pair is 3. 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. These match, so I did it correctly. So I have x minus 5 and 2x plus 3. That should be my answer there. For number 10, the first thing I do is look for a GCF. There is no number that goes into 1, 15, and 54. Second thing I notice is that it's a trinomial. So again, I'm going to look to see if it's a perfect trinomial. X squared is perfect, but 54 is not perfect. Therefore, it is not a perfect square trinomial. A is equal to 1, so I'm going to do big X method. 1 times negative 54 is negative 54. On bottom, I have b, which is 15. The 2 numbers that multiply to be negative 54 and also add to be 15 are 18 and negative 3. When a equals 1, I can go straight into my factors. I have x plus 18, and I have x minus 3. For number 11, the first thing I have to do is look for a GCF. 3 goes into all of these numbers, so I can factor that out. If I divide everything by 3, I get 2x squared minus x minus 10. In the parentheses, I'm left with a trinomial. This is not a perfect square trinomial because 2 is not perfect, neither is 10. A is greater than 1, so I'm going to have to do my split the middle process. Okay, to start with, I'm going to do a big X. On top, I have a times c, so I have 2 times negative 10, which is negative 20. On bottom, I have b, which is negative 1. The two numbers that multiply to be negative 20 and also add to be negative 1 are negative 5 and positive 4. Now I'm going to do that split the middle process with this new trinomial. So I have 2x squared and I have a negative 10. My two middle terms are now going to become a positive 4x and a minus 5x. It doesn't matter the order of these two terms. I just chose to put the 4 with the 2 and the 5 with the 10 just to make my grouping easier. So I do big X, I do my split the middle. Now I'm going to have to do grouping. The GCF of this first pair is 2x. 2x squared divided by 2x is x. 4x divided by 2x is 2. The GCF of the second pair is negative 5. Negative 5x divided by negative 5 is x. Negative 10 divided by negative 5 is 2. This matches this. So x plus 2 is one factor, and 2x minus 5 is the other factor. Now, I can't forget this GCF of 3 that I took out way back there at the very top. For number 12, the first thing you always do is look for a GCF. I know that 2 goes into both of these numbers, so I can factor that out. 2x squared divided by 2 is x squared. 8 divided by 2 is 4. In the parentheses, I'm left with a binomial, which again, the only possibility for that is a difference of two squares. This is a difference. There's a subtraction sign. X squared is perfect. It's x times x. 4 is also perfect. It's 2 times 2. So this is a difference of two perfect squares. So I'm going to have x plus 2, x minus 2, and then I have that GCF of 2 out here in the front. Remember, the general format is one addition, one subtraction. That's where I got those signs from. For number 13, the first thing I do is look for a GCF. I know that 9 goes into both of those numbers, and I also see that they both have at least an x squared. So I'm going to factor that out. 9x cubed divided by 9x squared is x. 99x squared divided by 9x squared is 11. And since I just have a binomial here in the parentheses, I look to see, is it a difference of two squares? No, that's not a difference of two squares. So the only thing I can do on that one is factor out a GCF. Then I look at number 14. I see a 1 and a 25. There's no GCF to factor out. And it's two terms. So again, the only possibility here is that difference of two squares. X squared is perfect. 25 is also perfect. However, this is not the difference of two squares. This is the addition of two squares. So this is prime or not factorable. All right, for number 15, first thing I want to do is look for a GCF. There is no number that goes into 1, 5, 3, and 15 besides 1. So there's no GCF to factor out. I see it has 4 terms. The only possibility for 4 terms is that factor by grouping. So that's what I'm going to do here. I'm going to group the first pair, group the second pair. When I look at this first pair, I notice that both of them have an x, so the GCF is x. xy divided by x is y. Negative 5x divided by x is negative 5. Looking at this second pair, negative 3 goes into both of those. Negative 3y divided by negative 3 is y. 15 divided by negative 3 is negative 5 as well. So these match. I have y minus 5 and I have x minus 3. For number 16 here, again, the first thing I always do is look for a GCF. There is no number that goes into 1, 6, 7, and 42 besides 1, so there's no GCF to factor. It has 4 terms, so the only thing to do here is grouping. The GCF of this first pair is x squared. X cubed divided by x squared is x. 6x squared divided by x squared is 6. The GCF of this second pair is negative 7. Negative 7x divided by negative 7 is x. And negative 42 divided by negative 7 is 6. These match, so I did it correctly. X plus 6 is one factor, and then x squared minus 7 is the other factor. For number 17, I'm going to look to see if there's a GCF. There is not a GCF here. I notice it's 3 terms. So first thing I'm going to do is check to see if it's perfect. 8 is not perfect, neither is 3, so this isn't a perfect square trinomial. A is greater than 1 in this problem, so I'm going to have to do split the middle. To start that process, I'm going to do my big X. 8 times negative 3 is negative 24. B is negative 2. The two numbers that multiply to be negative 24 and add to be negative 2 are negative 6 and positive 4. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. I'm going to do my split the middle step. I'm going to have 8x squared, and I'm going to have the negative 3. My two middle terms are going to come from these values. I'm going to write the 4 first. So plus 4x and then minus 6x. I do big X, I do my split the middle, and then now I'm going to do grouping. The GCF of these first two is 4x. 8x squared divided by 4x is 2x. 4x divided by 4x is 1. Anything divided by itself is just 1. The GCF of the second pair is negative 3. Negative 6x divided by negative 3 is 2x. Negative 3 divided by negative 3 is 1. These match, so I did it correctly. I have 2x plus 1, and I have 4x minus 3 from this GCF here. For the last problem, the first thing I do is look to see if there's a GCF. There is no number that goes into 1, 27, and 72 besides 1, so there's no GCF to factor out. Second thing I notice is that it's 3 terms, so I want to check to see if it's perfect. X squared is perfect, but 72 is not perfect. So this is not a perfect square trinomial. Then I want to look at A, and I see that A in this problem is equal to 1. So I'm going to do my big X method. 1 times 72 is 72. B is negative 27. So I need to think of two numbers that multiply to be 72 and also add to be negative 27. And I find that that's negative 24 and negative 3. Since A is equal to 1, I don't have to do this split the middle process I did over here for when A was greater than 1. I can just go straight into my factors. So my factors in this case are x minus 24 and x minus 3.